Okay, so let's go again. We've got this. We've got a lot of things started on this robot. Um, we can put the servos on it, and we can put a leg on the servo, and that can. But it's limited. Would be really nice if we had something we could do a flex joint that we could control a little bit better. And I'm going to step back a little bit. Let me go back to the document camera here. Now, a long time ago, when I first got the 3D printer, somebody showed me this. And this prints just like this. Now, remember that when you 3D print something, if it's molten plastic, you know, it comes out the print head and it cools down and it solidifies. So the print head just kind of like, it just goes, does whatever, okay, and things like that. And when they showed me this really fascinated me, as simple as this is. Easy, simple minds easily amused? Okay. This is a cell phone holder. And you basically, it comes up like this, and you set it like that, and then you can set your phone in. Okay. Works really well. Now, when I saw this, the thing that fascinated me by it was it printed in one piece. It prints just like this. But when you take it apart or take it off the print bed, it's got hinges. And I'm like, that could be really useful. And I was fascinated by that. Now, this came off of a website called Thingiverse. They got lots of stuff out there. I've talked about them before. And so I went and looked at the files for this, and it was actually done with OpenSCAD. And what they do to make this work is they do kind of a 45-degree pin and socket. So in here, this part here has a pin that sticks out like this, and in this part over here has a socket that's the same shape. But they're about 0.6 millimeters apart. And, you know, it kind of seems to violate our rule that we can't print in midair, but it really doesn't. There's 3 parts here. All 3 parts are flat against the build plate. And we can actually print overhangs of about 45 degrees. So if I make this pin that sticks out at about a 45-degree angle and I make the socket about a 45-degree angle, that'll work. So what I did was I sat down and I worked out, just like we did the servo. You can make modules that do this type of thing for you so you don't have to work it out all the time. And instead of you trying to figure out all that stuff, it takes a lot of prints, you know, and since I got a printer behind me, that wasn't a big deal. But, you know, trying to get you to do that, you know, it's a day or two between turnarounds, and that makes things too slow. So let me just give you that. Now, let's go back to, this is where we left the last one. Now, don't move around on me here. This is where we left the last one. And I'm going to turn this off for a moment. And then I want the same thing. Oh, let me save this as the next version. Save as. And this is going to be 6. I will push these files up to the file section. Okay. So we're back to nothing. Okay, fine. Let's see. I want, let's see here. Okay. I want this stuff. Now, I've got this library pre-done. And it actually looks like this. But I've got a module stuck in it right now, and I don't really want that in here. Let me get rid of this. This is what it looks like. And the code is too small, so let me make that bigger. So here's the code that makes the thing I was just talking about. And here's me calling it. And I said I want 5 millimeters and the 0.6 for the tolerance, 50 millimeters long and 45-degree rotation. You can actually fix the rotation. You can say I will only run it 0. And that should... So it's the two cubies on the end that turn. So this is the design that has... You could barely see it in here. This is the pin. And then this cube over here has the socket on it. You know, I can make it easier to see. I can do a difference. Put in the hinge. And then take out a cube. And I'm going to make it big. I'm just going to make it. And it'll probably just make everything go away. And I need to close that difference. Nope, it did exactly what I wanted to do. It took out part of it. So I subtracted off things, so now we can see. We can see how this thing works. In fact, if I translate it, it's centered. So if I translate it down, I should be able to get the whole thing cleared. Translate 0, 0, minus 10 is enough. I can't spell. Oh, commas, not decimal points. Okay. Okay, so cutting away half so we can just see what's inside it. What we can see here is these parts don't really touch, which is fine. That's really what I want. But when I go to print this, I can actually make it do something that we normally don't see. So this was what's going on inside. Okay, so now I can just copy all of this code and stick it in our robot, but I've got it in the same directory. So, and it's called pin socket. So let me do something else here. Let me just comment this out. So there is nothing that's going to be drawn. There's nothing. There's a bunch of modules defined, but it doesn't actually call any of them. So now let me save this and set this off to the side for the moment. And then clear back at the beginning of mine. Now this is now version 6, and this today is the 30th. I can say, instead of putting all the stuff from the other file in there, I can just say include, and I can tell it what file to include. This is called pin socket. So if I do something I use a bunch, I don't have to keep copying and pasting it in, because then if I make a minor change to it or something like that, then which one's got the current version and stuff. So this pin socket routine actually just goes in for me, and it makes it much easier. Now, I don't call anything out of that yet, but whenever the program goes through and looks at this for our robot and tries to draw something, it actually includes that entire file. So now if I go to the bottom here, I can include that thing that we did earlier, that hinge function. Remember, so I can come up here to this, and I just want this piece. I just for an example, I can just copy that out, go back to this is our code, and I can just drop this in here. And now when I say draw, there it is. That just keeps our code really clean, makes it much easier to deal with. Okay, so now how do I make this do something that I want? Well, getting carried away with this is really easy. I did another project a while ago. Let me flip back to the document camera. And this never got all the way to completion, but it, just gives you an example of all the bits and pieces of things that you can do. And in here, you see all sorts of things going on. Here is those hinges. I know it's black. It makes it really, really tough to see. But this rotates. And then this one does too. Now, the other thing that we've got in here that we haven't really covered is the ball joints. And we'll cover those in just a moment here. But so now when the servo moves, I can actually make an arm that is hinged that actually moves. Now, this is just to give you ideas. I'm not saying that you should copy this one, but it's just for ideas. And this up here actually is to hold a battery. And then this flat plate here is where I rubber band the control board to it. So it can all be all self-contained. At least that was my idea. Well, that was a year ago, and I got sidetracked onto 50,000 other projects and never got the rest of it done. Okay, a quick thing on ball joints. Same thing. If I make a ball on one side, and if I make a socket on the other, then when I print them, if there's enough flex in there, and if I get the dimensions right, they now also flex. But they give you a lot more flexibility and direction and stuff than the hinge that we just did. So I'll include the file that can do those too, just so you can play with that. Now this one's kind of fun. It's a 10 millimeter ball, and it gets these can actually print assembled already, or you can snap them and unsnap them. I got carried away printing these things, and these two came out of here. So this would have to go. Okay. But you can see that this, even though it's a very stiff, hard plastic, we can have flex out of it. It's just a bizarre thing. So, I'll probably shoot another video on how these are put together. But we can do the same thing here. So we got the pin bars now, and we've got the other. And we'll see what we can do with this. I'm just trying to get a few more options for you to think about when you're building stuff. Some of the groups in the past didn't use either one of the pin joints or the ball sockets. So almost anything you can make work is fair game.